Assalamualaikum and good day everyone. Welcome back. In part 2 of Module 2, we'll continue exploring descriptive and inferential statistics, focusing more on graphical and summary representations, and wrapping up with inferential concepts. By the end of Module 2, you should be able to explain two major categories of statistics, descriptive and inferential. After organizing data into frequency distributions, we can visualize it using graphs. Graphs are powerful tools. They allow us to quickly identify patterns, trends, or anomalies. They are often more effective than raw numbers for communicating data in presentations and publications. A histogram uses vertical bars to show the frequency of classes. The bars are touching because the data is continuous. Let's walk through how to construct one. Label the x-axis and y-axis. Plot class boundaries on the x-axis and the frequencies on the y-axis. Draw bars for each class. This example here shows temperature data from all 50 US states. A frequency polygon connects points plotted at the midpoint of each class. It's great for comparing multiple datasets. Steps include finding midpoints, plotting frequency points, connecting them with lines, and anchoring the graph at both ends with a return to the x-axis. The example again uses high temperature data. An OGIF shows cumulative frequencies, helping us understand how data accumulates over time or classes. Steps: calculate cumulative frequencies, plot them at upper class boundaries, connect the points, and extend to the lower boundary at the start. The same dataset is used to plot OGIF in this example. So, to recap, histogram shows raw frequencies, frequency polygon shows overall trends, OGIF tracks cumulative totals. Each of these offers a slightly different lens on the same dataset. In addition to these three types of graphs, other common graphical tools include Pareto charts, time series graphs, and pie charts. Let's now move to summary statistics, starting with central tendency, mean, median, and mode. This helps us understand the center of the data. The mean is the average, the median is the middle value, and the mode is the most frequent value. Each of these measures is calculated based on the type of data, whether it is ungrouped or grouped. Here's how those measures behave depending on the data sheet. In a symmetric distribution, mean equal median equal mode. In a right-skewed or positively skewed distribution, the mean is pulled to the right. In a left-skewed distribution, the mean is pulled to the left. Dispersion tells us how spread out our data is. Common measures include range, the difference between maximum and minimum, variance, the average squared deviation from the mean, standard deviation, the square root of variance, quartiles divide the distribution into 4 groups separated by Q1, Q2, and Q3. Interquartile range, the difference between the third and the first quartiles. High dispersion indicates more variability in your data. Now, we move to the second major category of statistics, inferential statistics. Unlike descriptive statistics, which summarize the data, inferential statistics let us generalize results to a larger population, make prediction or test hypotheses. Some common inferential tools include hypothesis testing, confidence interval, correlation and regression, and ANOVA and chi-square tests. Each is used depending on the data type and research question. That concludes Module 2. In Module 3, we'll move on to applying descriptive statistics to dataset.